All right, hello, this is Mr. Croce. I'm going to go over graph analysis number 1 worksheet with you. We have a graph here that's giving the height as compared to time. So we have height compared to time in this graph, and we have a height starting here, going up, down, across, up, down. All right, let's go through some questions here. Let's analyze this graph. What is the domain of this graph? Well, this graph goes from -5 to 7. Those are all the numbers that are in this graph. All real numbers from -5 to 7. Well, what about the range? Well, the range are the y values. Well, the lowest value is -8 here, and the highest value here is about 7.5. On the decimals, it's okay to round just to something close. Number 2 says, what is f of -5? Well, that says if the input is -5, which is right here, what's the output? Well, the output is -8. Well, what is f of 4? Well, if the input is 4, which is right here, the output is down to -2. So this is asking for the input going to the output. On the follow-up question is just reverse. It's asking for if the output is 3. So if I were to draw a line here at 3, let me draw a line at 3. There are two places, here and here, where the graph is 3, at about 4.5 and 6.8. At these inputs, you get this output. So inputs to outputs, outputs to inputs. Increasing, decreasing intervals. Well, this graph is going up to this point, from -5 to -2.5, and then it's going down from -2.5 to this point, and then the graph goes up a little bit from 1.2 to 2. Then the graph goes constant, and we have the constant down here, and then it goes up again and then down. So there's really 1, 2, 3, 4, 5, 6 parts to this graph. 1, 2, 3, 4, 5, 6. Up, down, up, constant, up, down. Relative maxes and relative mins. Relative maxes are this point and this point. They are a hill. It has to have a left side and a right side to it. And relative minimum is this point here. I had a lot of people ask, can you have 2 maxes? Well, yeah, you can have 2 relative maxes. However, you can only have 1 global max. This word here, global, means for the whole graph. This is the highest point on the graph. But these are also relative mins and max. And this right here is a global minimum. It is the lowest point on the graph. However, it is not a relative minimum. So you just identify the points. We have 2 coordinates for the relative maxes and 1 for the minimum. And those are the x, y points. All right, zeros of the function. Zeros of the function are where the graph crosses the x-axis. And what you notice about them is the y's are always 0. So there is no height. There's only an x value. So that's why it's an x-intercept. At those 3 points, it is 0. Average rate of change means slope. So the slope right here is at -5, the value is -8. That's right there. At 2, the value is -2. So if I were to draw this line right here, this line right here is the line that I need to find the slope of. Well, that line goes up 6 and over 7. From 2 minus -5 is 7. From -2 to -8, subtracted is 6. This line goes up 6 over 7. It's a positive line. At the value x is equal to -2. Well, let's plug that. Let's figure out where that point is. That point's right there. T is -2 right there. The position above the axis. The velocity, it's moving down. The acceleration, it's on the concave down part of the graph. Find and compare the 2 average rates of change. Well, you do the slope formula twice. y2 minus y1, x2 minus x1 is 7. That's this section right here. Very steep. From -5 to -4, very steep. from -4 to 2. A lot flatter. Steeper, flatter. The steeper section is 7/1. The flatter section is 3/2. Steep section, flat section. This one has a greater rate of change. When you compare stuff, you just want to tell greater than or less than. This side is greater, which means it's steeper. Where is the graph concave down? Well, I could highlight them on here. Let's highlight them, concave down section. This is all concave down, and that is all concave down to about right there. During which intervals is a function's rate of change positive? If a function's rate of change is positive, we have these three choices. Up in a straight line, which is constant, up in an increasing line, which looks like this, and up in a decreasing line, which looks like this. All of these lines are moving up. Every one of them, even this one right here, it's moving up, just slowly at the end. But we want this. We want an increasing positive graph. So that only happens on this little tiny interval right here. That little section of the graph from 1.2 to about 2. It's going up at a faster and faster rate. It's going up in concave up. This is going up. This is going up constant, going up, concave up, going up, concave down. So it can be going up and concave down. All right, hope this helps you prepare for side 2.